All right, so you'll see that when you open your R session, it looks just like as you left it. It's okay if it doesn't, but I didn't save anything and it still saves my history, which is really, really helpful. For the purposes of this workshop, I'm going to retype everything, and I encourage you to do that as well, because retyping it forces you to think about what you're typing and forces you to think about what each function does. That said, keep this open. So if you ever get stuck, if you have this available to you and you don't have a blank screen, keep this little script open so that you can always refer back. You know it works. You can just copy and paste it, worst case scenario. To open a new script though, go to File, New File, R Script. And you'll see a new script come up. And then right beside that one is the old one. If you get confused, it's there. Remember that R is case sensitive. It's really important that you type things exactly as they need to be typed, or else R just won't recognize what you're trying to tell it. So we'll quickly jump in. We'll do what we did last week, and then we'll get on to the new stuff, which is learning how to make plots, basic plots, how to customize those plots. And then we're going to make a word cloud, because that seems to be what all the cool kids are doing nowadays. So what is the first thing that we do when we open R? First thing, we go to Session, we set our working directory, we choose the directory, and we set where we want R to get the files from. So for me, I've put my folder on my desktop, and I'm going to be using this N8 text folder, and then just click Open. So a review for that, we go to Session, set working directory, choose the directory, and then pick the folder that you want to use. So the folder with your corpus. So last time we installed the package TM. We don't need to reinstall it because it's already on our system. So if you go to the Packages tab, for example, that lists all of your packages, you'll see that TM is already in my user library. If it's not in your user library for whatever reason, a reminder that the function you need to install the package is install.packages. And actually RStudio tells you what it is, which is nice. And then in bracket or in quotations, TM. And then to run a script or to run a command, click Control Enter or click this Run button. I don't need to reinstall it because I already have it installed. So to make the library run, to make it usable, you can click on this little tick box, which is the easy way. So you'll see that it's loading here in the console. Or you can use the function, which is library TM. And either one will work. It will do the same thing. So now that we have our library, remember that we had to get our working directory because we're going to be importing all the texts and we need to know where to tell R to get these texts from. So get WD, open brackets or close brackets. And you'll see here, it's users, me, Leah Henrickson. It's on my desktop in the folder N8 text. Easiest way to do this is to just copy that directory. Good. So to import our texts, and I'm going to use the same variable names that I used last time. So everything's going to have the same names. So I use texts. Remember that in order to name a variable, you use this little arrow hyphen. And we're using the corpus function. We're going to use a direct source. So dir source. And then in brackets again, that's where we will paste where we want R to get this system from. So texts is our name, our variable name, corpus with a capital C, dir source with a capital D and a capital S. And then we tell R where to go from there. And then run. And you'll see that this is showing up in the environment. So we've imported a simple corpus of 6 texts. And that is that, super easy. So last time we had a look at the text so we could see what we'd imported. Not going to do that this time because we know kind of what we've imported already. But remember, just a quick review. We use these things called, get transformations with a plural. We use these things called transformations to transform our text. And we use the TM map function to do that. It's called mapping the text. Last week, my help was not working. I realized after the fact that the reason my help wasn't connecting was because I didn't restart my RStudio after I had updated the appearance. So it should work now. So let's give it a go. We're going to use TM map. There you go. And we're getting all of the help for TM map. So if you ever get asked by anyone, if you're writing a paper or you're doing a conference presentation and someone's like, tell me about how you made your corpus nice, this is your answer. They also give some examples on how to use it and give you all the information. We're just going to do pretty simple things like we did last week. So remember last week, we changed our variable name. So we're going to do versions of our corpus to keep things easy. So if we make any mistakes, we can always go back. So texts1, our little arrow, and then the TM map function. And you'll notice in the console that get transformations has listed all of the possible transformations that we can use. And we're going to do all of these transformations except for the STEM document one. Not because it's not useful, but it's just not really what I want from my results. So you can always do that on your own, and it does work. It works quite well. I'm just not a fan of stemming in my own work. So what do we want to transform? Remember here in RStudio, it says TM maps X fun, which stands for function. So first we need to say what X is. So that's the corpus that we want to transform. And then fun is the function we want to use. And remember, these are our function options down here. So I want to change texts. That's our variable that we're changing. And I want to remove punctuation. And then I run this. I'll use this little button because I never use this button. And there you go. So we have a new version of the corpus with no punctuation. Quick, easy, no problem. Now we move on to texts 2, our second version. TM map, same thing, except this time we're altering text 1 because we're building on what we've done. And this time we're going to remove numbers. I did this with a cookbook once, and I had to remove all the numbers, and it just, the file looked ridiculous, but there you go. So we have texts 2, which has no punctuation and no numbers in it. We're all good here. Okay, great. Text 3. So our third one. This one's going to be a little bit different because it's a different function, but we still use text map. We're still going to do texts 2 because that's what we're altering. This time we're using something called content transformer or content underscore transformer, which itself is a function. So this is like, what is this? A function within a function? Maybe within a function? We have some layers of functions happening here. So we need another bracket to lower. And this will make our entire text lowercase. So TM map texts to content underscore transformer to lower. And we had a question last week about why you want your entire text to be lowercase. There might be some instances where you don't want a fully lowercase text, but this way it allows R to, remember R is case sensitive, it allows R to look at the text as a whole and not worry about, oh, the T in the is capitalized, so I'm going to treat this like a different word than the if it were all lowercase. This means that all words are treated equally. So depending on what you're doing, you might need that, you might not. And this is the one that takes a long time. So texts 4, TM map, text 3, remove words with a capital W. So remove is all lowercase, words is capital. Then we want it to remove stop words. So these are the things like the, and we want to tell it English because that's the language that it's using. So it's going to identify the English stop words. If you, I'm going to run it while I talk. If you're using a French corpus or a Spanish corpus, you can type in French, Spanish. There are quite a few languages that this allows you to do this with. Weirdly, when you type it in, you have to type the English version of that language name. So don't type like Espanol, type Spanish. But you can do this function for a number of languages and it will work fine. All right, so now, does anyone have any questions while we're waiting for stop words to do its thing? Yeah, that's normal. So it resets unless you save the kind of space and reopen it and go out of your way to reopen it. But as I don't know why it saves this, but it's like as a friendly reminder, it's like, here's what you did. But in order to do it, all you need to do is, or in order to get back to where you were, just set the working directory and then run the code. I would run it line by line just to keep it easy. And you can get that environment back to where it was before. But unless you've saved the R kind of session, and gone out of your way to save it, it won't save the environment. It won't save all that other stuff. You have to redo it. Yeah, you can copy all. So you could do that Control A or just paste it and then click Control Enter and it will run it line by line. You can also do that for various lines. So say you don't want to run the entire code, you only want to run these 2 lines. You can highlight those 2 lines and do that Control Enter and it will run it line by line for you. That would be a TM thing, I think. Most programming languages don't run very well in languages that aren't English. There's a really bad colonialist mindset in the programming world here. But I think that's a TM thing. I know that TM does allow other languages because I've done it before and I've used French and it has worked, but it might be that there could be another function that I'm missing. So for example, when you remove punctuation, my guess would be that's probably where RStudio is getting a little bit like, whoa. So again, this stuff, I know this stuff is in the TM package handbook. So I would encourage you to have a look at that after the session and see if there's anything maybe I'm missing. It's been a long time since I used a language that wasn't English. So again, I don't want to give you the wrong information. But I think, yes, there is a way to do this. There is a way around this. And I think it's a TM problem more than an RStudio problem. You can check if your texts are in UTF-8, you can check the file format in the properties. So if you right click on your text, you can check the file format, you can often change it. You can change file formats in R as well, but I'm not going to do that today because it's a little bit outside of what I'm doing. Which is also why I'm asking you to use .txt files, because those text files are often much, much easier to run and a lot less problematic. But hopefully that kind of helps. Meanwhile, we have texts 4, which is our corpus with no punctuation, no numbers, no uppercase, and no stop words. And then the final thing we need to do, we don't even need to do this, it's just nice and makes the code run faster, is we're going to do texts final TM map. We're altering texts 4. And we're going to strip white space. It's hard to see here, but the only uppercase letter on strip white space is W. So everything else is lowercase, and then we're going to uppercase white space. And we'll run that. So now we have our texts final, which is what we're working with. It's amazing. That took us, what, 15 minutes? And that took us an entire session last week. So the fact that you kind of understand what we've gone through, even if you need a little bit of help, a little bit of reference, you've already learned so much already. And it's amazing that, you can just do this. So remember that at the end of last week, we ended with what we call document term matrices. So we're going to make a document term matrix. In programming, A matrix is just a table. Those of us who didn't do maths or sciences at A levels or GCSEs or whatever, we would know this as a table. So a matrix is just that kind of, title with some information on it under it. It's called a document term matrix because on the y-axis, on the left side, I guess for you, I don't know what side I am for you, that's the document name. And then the term goes on the top. You can do a term document matrix, which is just the other way around. It honestly doesn't really matter, but I'm going to be using document term matrix, and everything I do going forward is a document term matrix. So follow along with me, but in your own time, if you find that term document matrix is more your style of reading and that's better for you, you can use it. Most people will go with DTMs though, and I'm going to do that today. So let's make our document term matrix. I'm just going to call it DTM. Super easy. We're not going to forget what that means. And the function is, drum roll, unsurprising, document term matrix with capital D, capital T, capital M. Remember that RStudio should be giving you little prompts. It's like, oh, I think you want this. You can just click on that if you don't want to type it. It's long. My fingers hurt from typing all day anyway, so I'd rather click. And then we tell it what we want to make a table of, and that is text final. That's our corpus, and then run that. And then what we ended at last time was we inspected our document term matrix. So we can use the inspect function to see kind of what that looks like. So you'll see here, and I was asked this last week and I didn't get a chance to answer the question, so I'll answer it now. On the side, like I promised, all of our texts, our 6 texts, are listed. And then at the top, we have the terms. And the document term matrix has just pulled out some of the most used terms. So we're seeing that, I think I calculated this at one point. I believe government is actually the most used term across the corpus. And then man and men, interesting because these are all books about women's suffrage and men are still at the forefront. So wonder what's going on there. Could be a really interesting research question. Then one, and then at the very end, we have this kind of woman man. It could also be, so what R's done is put this in alphabetical order as well, but I believe that man and men are still up there. So I might be getting mixed up, but they're essentially in alphabetical order. It's just pulled out some common terms. It doesn't really matter for our purposes because we're going to adjust this document term matrix. So it actually gives us the information and tells us exactly what the most used words are. So we'll get to that point. But there you go. So you have a little bit of a feel for what these texts are about based on the most common words in the texts. Reminder that if we had stemmed the words, man and men would show up as one, and woman and women would show up as one word. So if you're stemming, you get rid of the end part of the word, and they're often, they lump together. So now we move on to our new stuff. This is all stuff that we're just going to learn today. So in my code, I'm going to make a comment to myself because I can. So put a hashtag and it will turn a different color in RStudio, and you can write whatever you want. New fun stuff. Leah is cool. I'm writing lots of things, and it doesn't matter how many things you write because you have that little octothorpe at the front of your comment. You can write whatever you want. If you go to a new line, the text goes back to that regular color and you're no longer writing a note. So every time you want to write a comment on a line, make sure you put an octothorpe hashtag so that R knows not to run that code. Otherwise, it's going to try to run new fun stuff. Leah is cool. I'm writing lots of things, and that's not going to make anyone happy. So now we're going to figure out what the most used words are, because that's what makes word clouds. That's generally what we want in our plots. So let's count words. Remember that R is just a fancy calculator. So new variable name, because we're going to make a new thing that we want R to refer to. We don't always want to keep referring back to DTM. We just kind of want to have things quick and easy for ready access. So I'm going to make a variable called freak. FREQ, which is short for frequency. You'll note that frequency here is also a function, so don't call it frequency because that's a function and it's confusing. So just something short and simple, freak. We want to add up. So you'll notice in this matrix, everything is in columns. So each row lists, in American suffragette, the word government comes up 16 times. In female suffrage, 139 times. Well, that's all well and good, but we're working as a corpus here. We're working across the texts, not within the texts. So we just want to know how many times government pops up in our corpus. So we use the call sums function. So it's all lowercase except the S. That S is capital in the middle. And we're going to make a new table that is just the sum of all of those columns. So as dot matrix. In normal people terms, we're telling it as a table, put this in a table, but the function is as matrix. And the text we want to use is DTM. So we're turning this document term matrix into another table. That's going to be a much simpler table. And if we run this, we now have in our environment a large numeric table here. It's not even really, it's kind of a table, but it's just a large list of numbers. And we can see, so we can see into that table. If we want to look into it, type the name of the table. And then remember how we used square brackets last week if we wanted to look inside something. So if you have something, a variable and you want to look inside it, you use square brackets. And we use the colon to say, I want to know the first word up until the 10th word. That's all I'm telling it to do. So let's have a peek inside. So there we go. So the first 10 words that appear in our corpus are listed here. They are put alphabetically. So the first one is abandon, ABC pops in, abilities, ability, able, abominably, great word, abreast, abounded, broad. So these are just our 10 words. They're in alphabetical order. Fantastic, right? But not super helpful because it's nice that the word abominably comes in, but that doesn't actually tell us very much about the corpus. It doesn't tell us anything about what we're working with. So how do we sort this? There's actually, this is probably the easiest function in R. There is actually a sort function. Thank you. Great. They've thought ahead. So freak D is going to be my next variable name. Again, you can name your variables whatever you want. I'm calling it freak D because it's frequencies underscore decreased. So I'm going to put this in decreasing value, meaning I'm going to put the most referenced words at the very beginning, and we're going to go, decreasing from there. So then we're going to use the sort function. We're going to sort our data, which is in this table. If we ran this table as it was entirely, in its entirety, it would just be so many words, just a ridiculous. Actually, it would be 17,000 words. We can see this from the table here, and I don't have time or the inclination to read 17,000 words. I've read enough dissertations of that length this week, and I've had enough. So sort. We want to sort our freak. That's what we're sorting. So we're referring back to this, telling it exactly what we want to sort. And actually X is telling us, or RStudio is telling us here, decreasing is false. Now, if we put decreasing as false, which is the default, it means that it's just going to put it in alphabetical order. It's saying, do you want this in decreasing order? And false means no. Well, we want false to mean, where we want yes, we want this in decreasing order. So let's put decreasing equals, in all caps, true. And we put this in all caps because we're really excited about it. If you put all true in lowercase, nothing's going to happen. R is not going to recognize it. So whenever you say true or false, you have to say it with conviction and be like, yes, it's going to be true. And then run it. So now we have a new list where all of the column sums are put in decreasing order. So if we run freak.d. Last time we ran freak 1 to 10. Now we want to see what's up with the 10 most frequently used words. Freak.d, 1 to 10. And you'll see here, actually, I was wrong in the last interpretation. It looks like women and woman are the most used words, then suffrage. Men come in at a kind of a somewhat close fifth, a refreshingly far away fifth, actually, I think, for this topic. So women, woman, suffrage, one, men, will, upon, man, government, said. I quite like the use of the word will here. That's quite nice, very future thinking. All right, so we have our kind of top stuff here. What do I have next? Great. So you're off to a good start. If you wanted, you could do like 1 to 50 and get the 50 most used words if you wanted to. Doesn't really matter. I'm not going to do that now for time. But now let's say we only want to know the 100 most frequent terms. There is a function for this as well. You can do this a little bit easier. So if you just wanted to know this without doing this stuff, you could, for example, and I'm just showing you some options here, so don't necessarily worry too much about remembering this. There's a function called find freak terms. And we want to find the frequently used terms in our DTM column, because remember, I'm just showing you an option. So instead of this, you can do this. And then the lowest frequency. So I only want, for example, I'm only saying I want the words that appear more than 100 times in the text. And you can do that too. But as you'll see, again, this might be helpful for someone, which is why I'm including it. But this is in alphabetical order. It shows you all of the words. It's not in alphabetical order. Maybe it is. I don't know what order it's in. I never use this. But yeah, that's an option for you. And then I also, in the slides, I've put something called find assocs, which means find associations. For those of you doing prose analysis, like what we're doing here, this isn't a particularly useful tool unless you're using like 100 plus texts, in which case it might be useful. But for those of you doing things like social media analysis and like analysis of tweets, for example, this is really useful. So find associations means that you're looking across documents and you're finding words that appear in the same document. And it will tell you the kind of statistical probability of those words being put in the same document and coming together. Given the length of our documents, this isn't very useful for us, but I'm including this because I know quite a few of you said that you were doing social media analysis. So quick shout out to you people. If we do find assocs, DTM, and let's say we want to search for the word women. So words that show up with the word women, because women was the most frequently used word. And then this is where it starts to get into probabilities. So those of you who haven't done statistics, just know that a probability is generally statistically significant if it's like 0.95 or over. So let's see, there's a 0.95 chance. If it's 1, it means there's a 100% chance. Let's say there's a 95% chance of a word appearing with the word women. If you type this, it will show you all the words that appear in the same document as the word women. So for those of you, again, doing social media, the tweets and stuff, really short stuff, this is really, really useful. I like how Henry, there's a 99% chance it shows up in most of the documents. Round, office, 95%. And you can adjust this, this number as you see fit. But that's just a few little things. If you want to know more about the find associations tool, use the help. So that's how you would use the help. # find assocs. And it will bring you to all the information about finding associations. So just to let you all know that's a thing. But okay, let's move on then. So I'm just gonna actually remove actually, I'm not gonna remove that stuff. So let's put a comment, bar plots. We're gonna start plotting things. This is finally when you're gonna see the fruits of your labor. And it's gonna look really fun, and hopefully you'll see just how easy it is. We've done all the hard parts. The hardest part in any kind of text analysis, in R at least, is preparing your corpus. Python, it's also really kind of the most difficult part, is preparing your corpus. But we're going to make a bar plot, which is just a regular graph, pretty standard looking graph. And R has made this really, really easy for you. There is actually a bar plot function in R called bar plot. So type bar plot, then a bracket because it's a function. And what do we want the height of our bars to represent? Well, we want it to represent the frequently used words. And remember our freq D, our frequency decreasing, that lists the most used word to the least used word. So we want to use freq D. And if we just run it like, I'm not going to run it like this because my R will crash, and don't run it. Do not run this yet. If you just run it, it will make a plot of all of your words. So all 17,000 words will be represented in your plot. That's not ideal because no one's going to be able to read your plot and it's not going to serve any real purpose. So for the sake of our class today, I'm only going to run the first 10 words. That's all I'm interested in today. So we'll use our square brackets because we're looking inside this variable. 1:10. So bar plot, freq _ D, or whatever your variable name is, and then the first 10 things in that table, and then run. And you'll notice that in your plot viewer here, this graph has shown up. So really nice. It's looking kind of boring, but like it's there, you know, very quick and easy. But obviously we're not seeing all the words here, and that's a problem. There's no title, there's no side things, there's no labels for the X and Y axes. So it's not complete quite yet, but we have something there, which is nice. If you want to look at your plot in kind of greater detail, you can go to Zoom and it will open a new window, and you'll see that now we can see all of the words here. The bigger you make it, the more space you give R to do its thing, or the picture to do its thing, which is really helpful. So there's nothing wrong with our plot in the viewer here. The viewer is just a bit too small to show everything that we've made. And if you're really proud of your plot and you think, oh, I want to show this to all my friends, going to include all the papers, go to export and you can save as image or PDF. I tend to save as images, and then you can save, you can tell it exactly where to go. So you can click on the directory. This is what file or what folder you want to save it under. What image format you want. Generally, PNG is what you want if you're going to be publishing anything, but JPEGs might help. TIFFs are really large files, and then everything else is usually not needed. But if you're publishing, make sure that you know what the specifications are so that you can export appropriately. And then if you want to make this big, because we're seeing here, it's not big enough, we can change the width and the height. So say I'm going to change it to 1000 pixels. And then we can maintain the aspect ratio so that it adjusts, it doesn't squish in weird ways, it grows with the width. And then you can update the preview, apparently not, but let's save it just because we can. And there you go. We have quite a nice 1000 pixel wide basic bar chart. We're not using the plot.new function, we're using bar plot. So if you use the function bar plot, that's what you want, not plots, not regular plots. So great, so now we have this, but this is not a very helpful bar chart as it stands, because we have no idea what we're looking at. If we're an outsider coming in, I would just see women's suffrage and be like, I don't know what you're referring to. So you want to make this bar plot look nice. You might also want to add some color in there and really make it your own. So the easiest way to remember how to customize your bar plot is, surprise, going to the help. So we'll go to the help really quickly. And you'll see here, the people in the help have actually put all of the default settings up here for you. So everything that says null, it's saying don't include that. And right now, things like main is the title, for example, that's what they're calling the title. It's saying don't include a title. Don't include a subtitle. XLim, is the, sorry, X lab is the X axis at the bottom. And it's saying don't include anything. Y lab, the sideways one, don't include anything. Well, we can change that. And it's saying anything that says X lab equals null, we can just put X lab equals what we want. So let's give that a try. Say we want to put a title with our bar plot. I'm just going to copy this function. I'm going to copy and paste it so that we have a record of what we've done. So bar plot freak D, first 10 words, comma, and then remember everything, unless you specify otherwise, everything in this list here is going to be what appears. So I'm going to add a title, main, equal sign. Remember that you can put a space between the equal sign and what you put. It doesn't really matter. I tend to keep spaces out just because it's tighter and easier to read for me. But if it's easier to read, you can put a space before and after the equal. It won't change the function. Now you want to name your graph. Remember, it's a string. It's a string of characters, so you have to put it in quotation marks. And I'm going to name my plot or bar plot Leah's cool bar plot. Cool. And while we're here, we can also change the labels here. So we have main, that's my title. And then I'm going to put X lab, short for X label. X is that X axis. And then it even tells you in RStudio, there we go, a label for the X axis in case you forget. And then the X axis is the word. And we'll do the same for the Y label. So Y lab equals frequency. It doesn't matter, for the sake of this class, it does not matter what you put into the names. You can name your labels whatever you want. But let's run this and see what it looks like. There you go. So we can zoom in a little bit here. So you'll see that my main title, Leah's cool bar plot, has come up as the title. We had the option to do a subtitle, but I forwent that option. Then we have frequency here, and then word at the bottom. There are so many other ways that you can customize your plot. So if you are looking to make a really, really good custom bar plot, have a look at these different kind of qualifiers, I forget what they're called, at these different kinds of things that you can change. And you can change, you know, the frequency of the numbers on the side. You can change pretty much anything here. But now I want to add some color, because that black and white I find a little bit sad. This is not great. So let's add some color. How do we do that? This requires us to install another package because R doesn't have default color packages. And the most common package for adding color to any kind of graph, this is the one that you'll see pretty much everywhere. So we're going to install .packages. That's how we install packages. Remember at the beginning of this class and last week, we did that. Install packages. And then in quotations, and you put it in quotations because it's not in our library yet. So it's kind of telling R that, you know, this is not in our library yet. We need to get it. R ColorBrewer. So color is spelled the American way. And there's a capital R, a capital C, and a capital B. R ColorBrewer. And then install. It should not take too long to install. So we've installed our ColorBrewer. And this is the magical tool that will make our word cloud and our plot look fantastic and look appealing, which is what we want. We don't want a boring thing that looks like it's straight out of a 1970s newspaper. We don't have time for that. So let's turn our ColorBrewer on. Remember that to turn our ColorBrewer on, there are two ways to do that. So you can go to the packages thing here, the packages section here, and just click our ColorBrewer. I did that last time. So the other way to go about doing it, just so I can show you, is the library function. So it's saying go to my library and just type in our ColorBrewer. And now it's turned on so you can use it. So we're running our ColorBrewer. You can get some more information about our ColorBrewer by using the help. So the great thing about this is it tells you exactly how to use the tool. And I would encourage you, if you're going to use color, I would really encourage you to just read this short section, because it does really clarify things in a way that I just don't have time to clarify things today. It also gives you options on like how to use it. So examples on how it's used, and you can just copy and paste those to make them work for you. But the main thing that I want you to be aware of is this display brewer all, which displays a few palettes in another graphics window. So our ColorBrewer, the great thing is you can make your own palettes of colors. So you can say, oh, I'm doing a plot about Christmas, so I want to use red and green, I only want to use this. You can do that, but I'm a huge fan of the palettes as a non-artistic person myself. I have a lot of vision, but it never really comes out the way I want it to. So the palettes are a safe bet for me. So let's use this display brewer all and then close brackets, because it's a function. So when we run that, we get the palettes here. And the palette names are on the left-hand side, and the palettes themselves are here. The kind of annoying thing about this is it doesn't tell you how many colors are in each palette. You have to count them. And that becomes important in a second. But there you go. So make a note of one palette that really stands out to you. Just pick one. My personal favorite is the one called Spectral. I think it has a cool name. I like the colors. I'm going to be using Spectral, but you can use any of these. Remember, R is case sensitive. You need to make sure that you're capitalizing where it's capitalized here, or else it's just not going to work. So we can close this. You'll notice if you went to the bar plot thing here, let's go back to the help. There is a section for color under bar plot. It's called COL, call. But we need to tell it what palette we want. We can't just say color yellow. That's not really going to work very well. And an all yellow bar plot is really not any better than an all gray bar plot. Might even be worse. So let's set a parameter. Let's make a variable that tells R exactly what color palette we want to use. I'm going to call it cols, C-O-L-S, just because that's what I'll remember. So we're making a new variable, and the function we're going to use is brewer.pal. Pal in this case means palette, but it's also like a friend for colors. And it's a good friend for colors. So brewer.pal. And this is where the number of colors in the palette comes in. And I don't know why R does this. You can ask me and I'm going to be like, I have no idea. And it's really frustrating. You have to tell it how many colors from the palette you want to use. So there are 8 colors in the spectral palette, I think, something like that. I don't know. I always click 8 because I have no idea. So I want it to use the first 8 colors in the spectral palette. So cols is the name of my variable. The function is brewer.pal. The first 8 colors, comma, from the spectral palette, and spectral is in quotation marks. And then we'll run it. So now we have a variable with our colors, and it has the hex numbers in it as well. So if you ever want to know, okay, what colors did I use exactly because I want to match my website with my plot, or I want to match something with something, you'll have that information there. So we can use that. But so now we can make our bar plot with colors. Super easy. I'm just going to copy what I did before. So I'm going to click copy, and I'm going to paste it because there's no point in me typing it out right now. And then I'm going to add color. So COL is the vector of colors for the bar. And then cols. And there you go. It doesn't matter what order you put these qualifiers in. You can put them in any order you want. Even though they're in a certain order on the bar plot thing, it doesn't matter because R knows that what you're referring to because it's all within the brackets. So there you go. So now I have a lovely bar plot with the spectral palette, with my little labels on the side, with my title. And a reminder, if you want to save this so you can show your loved ones, which unfortunately I do, and my loved ones have to suffer through it, I'm going to make it a little bit bigger. So 1000. And the height will adjust accordingly as long as you have the maintain aspect ratio here. And then I'll save. And this is what my bar plot looks like. So you can play around with adjusting your bar plot to be exactly as you want it to. You can change the colors around. You can do your own palettes. I wish you all the best. I've yet to find a palette that looks nice to me. It's not hard to do. I'm just really bad at it. But there you go. You have this bar plot, which I think is quite cool. How do you adjust the axis so that it doesn't stop with 2000? For that, so head to the bar plot help. And I believe I've done this before. I believe it has to do with the X lim, which is limit, I think. We can actually check that if we use the help, I think. When you have a question like this, the easiest thing to do is just kind of look at these and be like, what could it be? And then double check it. But you want to do the X lim. Right now it's null. So it's just going to be, you know, up into a random kind of where it thinks, okay, this is a good place to stop based on the information you've given it. But you can play around with those parameters by playing with these here. Is it not slim? It could be the slim. Where is that? S lim. It would be X lim and Y lim. Because the Y lim, yeah, it would be the Y lim. Yes, it would be the Y lim because it's the Y axis. Good catch. Yes, you're right. It should be the Y lim. All right, awesome. So no other questions, fantastic. So we'll move swiftly on to word clouds and then we'll review some of the resources that are available to you. It's the same bunch of resources I recommended to you last week. So you'll get a bit of a refresher there. We'll have some last minutes for questions. And then we'll all be on our way. So the next thing that we're going to do, we've learned how to make a bar plot, and we'll give our bar plot one last kind of moment of admiration before we move on to our word clouds. A reminder that word clouds are really not scientifically very valuable, but I find word clouds really useful for, you know, good things to supplement conference presentations to give people something fun to look at. Really good tools for also pulling out words and making, for those people who are more visual thinkers, might benefit from word clouds as they kind of make very clear what the most frequently used words are. You can get that in this plot as well. And what's really interesting about this plot as well, for those of you who are interested in the science of this, I'm not going to go into depth, but this illustrates what we call Zipf's law. So Z-I-P-F. So Zipf's law. And it means that whenever you count words this way, it'll always be the same shape. So it doesn't matter what texts you use, your bar chart will always be the same shape, which is really interesting because the number of words goes exponentially down. I don't know, there's science behind it for those of you who are interested. But word clouds I find really good for kind of early research when you're just trying to feel like, I don't know what the patterns in the texts are. I don't know what the most common things are. I find word clouds just immensely useful, but they're more of a supplementary visual than a kind of evidential visual for any kind of paper you do or conference you do. So just fair warning, I think they're great. All right, so in order to do this, we need to install the word cloud package. So again, we'll install another package, install.packages. I can spell packages. Word cloud. Goodness gracious. Word cloud. And now we have our word cloud package. There is, fair warning, there is a newer version of the word cloud package as well. It's called Word Cloud 2. The reason I'm not teaching it is because I have had a lot of difficulty with it and I still fall back on this word cloud package. I'm trying to move forward to word cloud 2 though, because word cloud 2 allows a lot more customizability when it comes to the shape of your word cloud. So you could do a pentagon, you could do a star, you could do a square, a circle, whatever. Word cloud 2 allows you to do that. Word cloud 2 also allows you to input your own image so that you can make a word cloud in the shape of that image, which is really cool if it works. And other people, it works fine for other people. It doesn't work well for me. So I'd encourage you to check out the Word Cloud 2 package, which works basically the same way as this package with some added functionality. So fair warning. So now we need to turn this package on. So library, Word Cloud, or just tick the little box, whatever you find is most useful. I just like feeling like a programmer and putting it in manually, but it does take a little bit more time. Now, okay, this is where this requires a slightly different format for our data. This is not an easy way of making a word cloud, but you can do it. We're going to disregard a lot of the things we did to prepare to make our bar plot. And we're just going to go back to that document term matrix, the original thing that we were working with on line 11 for me, that document term matrix. We're going to use that as the basis because we need to prepare our data slightly differently. So let's make I'm just going to call it matrix, just to make it easy. We're making a table. And we're going to use that same as.matrix tool. And then DTM. So we've done this before with our freak variable. But we're just going to make a separate table for our word cloud. So now we have a table called matrix. We're just changing file formats at this point. So the information in the file is the same. But in order to make a word cloud, it's a bit picky. You can't make a word cloud out of a document term matrix. You have to use a regular matrix, a regular table. This is like, it's all about file formats, and I can't get into it. It's too much detail right now, but that's what we're doing. So then we're going to make our list of words that we want to include in the word cloud. So I'm just going to call this variable words. And we're going to use our sort function again. So this is all going to look a little bit familiar. So sort, and we still want to do our column sums, because remember, we're not working in certain texts for this class. We're working across an entire corpus. And we want the column sums of our matrix file. So we're trying to get the column sums of the matrix file, because remember that matrix file has the documents on one side and the terms on the top. But we don't need the documents. We just need the final number. And then we want all of these sums to be in decreasing value. So remember our decreasing, true. And it's in all caps because we are thrilled. So now we're going to have a new list of words, a table with a list of words that's just the number of times each word appears in the corpus as a whole, from most to least, and then run that. So our list of words here, we have our 17,000 words from most to least. And then, okay, this is when I said it wasn't the easiest thing to do. It's unnecessarily complicated to make a word cloud. It's a little bit easier if you're doing it with a single text and you approach this a little bit differently, but it's okay, we are not deterred. So we're going to use something called a data frame. I'm going to make a variable called df, just so I know it's data frame. Now, the function is data.frame. It tells you, okay, word is the parameter. So what word do you want to use? Well, I want to use the name. This is really complicated. So word equals names. That's the name of each column. And we're talking about the name of each column in the table called words, if that makes sense. We're going to rush through this. I do not have time to explain every single thing. So I'm just going to apologize now profusely. But word equals, that's the parameter for the function, the names of each column, and the table that we're referring to as words. That's what that means. Then freq, which is the frequency of words. So how many times each word appears, and we're still referring back to this. Again, I'm really sorry. This is not clear, and believe me, it's still not clear to me, and I've done this so many times. So there we go. We now have a data frame of 2 variables, and those variables are the word itself and the number of times it appears. So the column name and the number in that column. If you want more information about the data frame function, go to the help, because that will help you much more than I will. And you can get all of that information here. All you need to know, worst case scenario, you want to do a word cloud, just use this and fill in the blanks with your own variable names and you'll be fine. So now we're actually going to make a word cloud. We've done this unreasonably complicated set of functions. We've pulled some hair out. We've had a good time. And now the word cloud, just to add insult to injury, the word cloud function, we're going to use the word cloud function. That's the function name. So remember function and then the brackets. And we need to tell it the words we're going to be using, the frequency. Oh, sorry. God, sorry. It doesn't matter. Anyway, so word cloud. So we need to tell it what words we're going to use, what the frequency is, you know, how many words we want to include in our word cloud. So the words we're going to use equals, and remember here, we actually named it. So there's df word. That's what we named this. This is where it's not clear. So there we go. So we're going to do df. And because we're working in tables, normally when we work within variables, we work with those square brackets. But because it's a table, it's a little bit different. And we need to use the $sign. So we're saying df, and somewhere within this table, we want to grab something. And the thing we want to grab is word. So that's the word that we're using, or the words. Then we want to do the same thing with frequency. So freq equals df $sign freq, because we named it freq. Okay. Stay with me. It's going to be a great word cloud, I promise. All right, so we have our frequency here. And then if we do our word cloud just like this, it's going to show us all 17,000 words. And I do not want a 17,000 word cloud. I don't think anyone wants a 17,000 word cloud. So let's say the max words, that's the parameter, max.words. We only want the 100 most used words. 100 sounds like a lot, but then you'll see the word cloud and realize actually it's not that much. Word cloud, the word cloud function will put all of the words into a random order if you tell it, unless you tell it otherwise. So we don't want our words in a random order. We want them to be the most used words are bigger. If we put them in a random order, they're all the same size. So random.order equals false. I'll explain this in a second. Because we don't want them in a random order. We want them in a planned order, which is the most used words are biggest and in the middle. And then because we have our color palette already set, we can use the same color palette. So remember I called mine calls and it's the same. So COL is the same parameter. And if we run this, it makes a word cloud. We can zoom in. So this is 100 words. This is what I said when, be surprised at how little space 100 words actually takes up. But it brings you the same information we had in that bar plot in a slightly different form. So we have this word cloud. Remember that word cloud 2, that package. You can change the shape. You can have a lot more flexibility, but this is a pretty basic word cloud that I think looks pretty nice. We could always change the parameters here. So you could do 200 words if you wanted to and try running again to see what that looks like. So see if that better suits what you're looking for. Let's zoom in with that. There you go. It looks a little bit different. It's updating, which is why it's going back and forth. So it's running through the text. And sometimes plots will do this when there's a lot of work to go into it. So when there's a lot of computing power needed to make this, you'll see it updating, and we might just give it a little bit more time. So that's what's happening here is it's updating the data. And now that it's stopped, we know that the function's done running. So with 200 words, we just have a little bit more stuff along the side. And the spectral color palette is what I used before from our ColorBrewer, and it's being used here. So with the darker in the middle, that will change depending on the palette that you use. So if you have any more specific questions about the word cloud function, again, go to the help. And as you'll see here, they tell you what the default settings are. So you can change the colors, you can change the random order thing. You can have something in a random order and just have it all words being equal. I find that really unhelpful and kind of defeats the purpose of a word cloud, but okay. You can have a minimum frequency. So remember earlier on in the kind of find association, not find associations, the, what was it called? The find frequent terms, we set a low frequency of 100 word times, or sorry, 100 instances of that word or more. You can do that here. So you can say, oh, I only want to know what words appeared 200 times or more in the corpus. You can do that. There's a little bit of layout option here that, again, just doesn't really work for me ever, but you can try it. I've not managed to do it successfully. And then they give you some example uses of word clouds that you can play around with. So again, word clouds are surprisingly very, very complicated. And I would recommend using R for word clouds when you want to make highly customized word clouds. But to be honest, there are tools online that can do it just as well. The great thing about R is that you can remove the stop words, make everything lowercase. You can just make sure it's clean, the text is clean before you do anything with it. That's the advantage over the online tools. But many online tools, things like Voyant tools, for those of you who are interested, Voyant being V-O-Y-A-N-T tools, they do stuff like this as well that you might, if you're just looking for a quick and easy word cloud, that might be a better option. But this is really customizable, if not a little bit difficult. So those are our word clouds. Everything I've done today is in the PowerPoint. Remember that you don't have to remember all this. You can do this on your own time. The PowerPoint slides have not changed since I made them. So on that note, I'm going to slide my PowerPoint over. So this is what I'm working on. You'll notice in my PowerPoint that I've given you some examples as well. I've given you a little bit more to go off of so that if I'm not here in front of you, you can kind of get a reminder on what we worked with and how I'm working here. But let's just finish off with a review of these resources. And I did review these resources with you last week, but I want to drive it home that our parts of R are really, really easy. And as you've seen, parts of R are really complicated, almost unnecessarily so. But there is so much help out there for you. So I have 3 slides of help, and you can pick which ones work best for you. So if you think, actually, I really want to go into R, I want to talk to other people who are interested in R, I want to ask them very specific questions, you can go to any of these spaces and there will be people there ready to welcome you. All of these communities I found quite welcoming. There are, for women who are in R Ladies is quite good. They organize meetups. For people in traditionally marginalized communities, there's R Forwards, which is really great. There's the Reddit and the Twitter hashtags, but then there's also just general R communities that are run by RStudio and Stack Overflow. Stack Overflow is like the go-to place for programming questions. So if you have a question, someone else has probably already asked it on Stack. The other place that I would like to recommend, these are all tools for learning. So if not so much have a question, but you're like, I want to explore different things that R has to offer, or I want to see how other people teach R. These are some of my favorite resources. So we have in this list a few general introductions to R here. These are text documents. They're very long, but really informative. There was a great reproducible analyses in R session run by N8. Emma ran that one, and the recordings from that session are available here. And I really enjoyed reviewing R functionality with Emma. I think she was a great teacher, so I'd recommend that. And then I cannot stress this enough. We stress this to our students, hopefully, to use LinkedIn Learning. But LinkedIn Learning has such a fantastic R kind of set of resources, especially if you're doing social media analysis or company business reports. There are full courses dedicated to that. And I think most of them will use the TM package from what I've seen. So what you've learned today will be really helpful if you choose to do those courses. And then if you're doing text analysis from a literary perspective, especially if you're just analyzing one or two texts, Matthew Jockers is what I always use when I'm doing that kind of teaching. I use that as a foundation. He provides a really good overview on how to analyze single long form prose texts, whereas I've used 6 texts. So that's a fantastic book. That is me pretty much done. If you want to get in contact with me for any reason, my email address is here, l.r.henrickson@leeds.ac.uk. I'm quite active on Twitter, so my Twitter handle is Leah Henrickson. It's my name. So thank you for coming. This has been an absolute joy.